All right, this is Mr. Crozier, and this is review sheet number 2. Like I said in class today, I'm going to go through the odds here with you. So here we go. Our job is to solve this equation. Well, we have the trig function isolated, but we generally don't work with cosecant or secant. So let's go ahead and change it to cosine of 3x over 2 is equal to, that'd be a negative 1/2. All right, so then now the deal is, when is cosine negative 1/2? And again, this is going to change our interval answer. So let's go ahead and get the general answer first. Well, when is cosine negative 1/2? Cosine is negative 1/2 at 2 pi over 3. Again, I didn't solve for x, so I brought this down here. And over here, I'm going to do the same thing because there's another place where cosine is negative 1/2. Remember, if I draw these triangles, it's going to be those tall, skinny ones. And it's going to be 4 pi over 3. And I put the
Just a reminder, the policy committee will be meeting in the library
both
now.
of them. So I have the general solution solved for 3x over 2. But now what I need to do is solve it for x. And what I can do is multiply both of them by 2/3 on both problems. Because if I multiply 2/3 times 3/2, that's going to be gone. So the x is going to be, that'd be 4 pi over 9 plus 4 pi n over 3. And there's one part of the general solution. And over here, I'd have 8 pi over 9 plus 4 pi over 3n. So there's my two general solutions. I have this branch, which would be this top one and this bottom one. But again, they've been changed. They're not these initial angles because this argument here has changed it. All right, so what's my general solution? What's my interval solution from 0 to 2 pi? Well, I'm going to start here with 4 pi over 9, and I'm going to add on 4/3. All right, so let me come over here, and I have 4 pi over 9, and I'm going to add on 4 pi over 3. And if I add on this, I have 4/9. What is this? If I multiply it by 3, that's 12/9. So if I add on that, I have 16 pi over 9. That's going to be my second solution. Now, if I add on another 12, it's going to put that at 28. And 28 out of 9 is more than 2 right here. 28 pi out of 9, that's more. So it's going to be too far. And then now I'm going to start at 8 pi over 9. And I'm going to add on that same thing here. Let's see here, 8 pi over 9, adding on another, what would that be? 12 pi over 9 would be 20 pi over 9, and that's out of the range too. So there's my 3 solutions. And again, take the time to check these on Desmos. Graph for yourself on Desmos. Y is equal to secant of 3x over 2. And y is negative 2. If you graph those two, you will see they touch at these 3 points. All right, number 10. And going back to number 8, when you have this argument here is not x, you're going to be best to get the general solution and then go down here. It's going to be easier that way. It just takes more work when you see that. So number 10, all I see is x here, so hey, everything's good. Let's go ahead and swing that over there, and we have 2 cosine 2x minus 3 cosine x plus 1 is 0. Now it's just something we factor. You can guess and check at this, probably the easiest way. And solve them both. Cosine of x is 1/2, and cosine of x is 1. What are those solutions? Well, it's just going to be pi over 3 plus 2 pi n and 5 pi over 3 plus 2 pi n. This is when cosine is 1/2. When's cosine 1? Well, that's just starting at 0 and adding on 2 pi n. What's the interval solution? Well, it's all of these. It's 0 and pi over 3 and 5 pi over 3. Interval solution, general solution. We could simplify this down, right? 0 plus anything is just 2 pi n. We don't need the 0 on there. All right, and the last one. Looks like a lot on number 12, but this is just a different variable, letter beta, but they're just x's. Nothing's different. All right, what do you see here? Well, mathematically, I have 2, and then we'll call this the A, and we'll call this the B, and we'll add on, well, hey, I have another one of these, so this is mathematically how I see it. 2 times something and something, and then plus another something, which is related to here, so I could just factor this out. So if I factor out this cosine, I have cosine, I'm just going to write x just to, it's simpler. 2 sine x plus 1 is 0. And if I multiply that back in, I'm going to have 2 sine cosine, which is right there. And if I do cosine times 1, I'm going to have cosine. So now I can solve both of these with, this is going to be cosine of x is 0 and sine of x is negative 1/2. And what are all my solutions here? Well, one's cosine 0, well, that's at pi over 2 and 3 pi over 2. And one is sine negative 1/2, well, that's at 7 pi over 6 and 11 pi over 6. And we don't have to worry about the interval changing, so those are all the solutions. And the general answer would be taking all of those, every single one of them, and adding on a 2 pi. And I'm not going to write it all out here, but you just have pi over 2 plus this plus this, this plus this, this plus this. Nothing can be combined, and since there's just an x there, we don't have to worry about this interval changing. All right, I hope this helps.